Okay, well, it is 2 o'clock in our Boulder time zone. There's going to be quite a few more people joining in the next few seconds, I'm sure, but I think we should get started. I'm Freddie Bloom of UNAVCO, one of the local organizing committee chairs, and I'm pleased to introduce my longtime UNAVCO colleague, Glen Mattioli, who for the past 10 years has been the Director of Geodetic Infrastructure at UNAVCO. Before that, he was a professor at the University of Texas at Arlington, where he still has adjunct status. And prior to that, been at the University of Arkansas, University of Puerto Rico at Mayagüez. At UNAVCO, he oversees the planning, construction, operation, and maintenance and data flow of hemispheric scale geodetic networks, many of which we'll talk about, as well as some international collaborations in Antarctica and the Arctic. He got his bachelor's degree from the University of Rochester in geology, and then master's and Ph.D. in geological sciences from Northwestern University, and done postdocs at Caltech and UC Berkeley. With that, I would say if you have questions, please put them in the chat, and we will have a few minutes at the end of the talk to ask questions. And with that, here's Glen.
Hello, everybody. Thank you for giving me the opportunity to address this IGS virtual workshop. I appreciate the invitation from the organizing committee. I'm going to turn my video off because I don't think you really need to see me during the course of this presentation. My talk is entitled "The Role of UNAVCO in the GAGE Facility in Supporting the IGS and Global Geodesy, Current Status, Upcoming Changes, and Ongoing Challenges." And thank you, Freddie, for that very nice introduction. So the talk is going to be presented in 5 different sections. The first section will deal with the UNAVCO mission, community science vision, and GAGE-GI program. The next section will be about UNAVCO and the IGS and support for the NASA Space Geodesy program, global GNSS network, and the IGS Central Bureau. I'll discuss a bit about NOTA, which is our largest network that we support. It's a hemispherical scale network that federated the former EarthScope Plate Boundary Observatory, the Caribbean-wide network called COCONET, and our network in Mexico called TLELAC-NET. I'll give you a few science snapshots from NOTA based on terrestrial GNSS observations, and then we'll discuss a few challenges going forward. The first section, UNAVCO mission, is pretty straightforward: to facilitate geoscience research and education using geodesy. And our vision is to transform the understanding of Earth systems and hazards using geodesy. And we do this through global leadership, facility operations that integrate innovative geodetic technologies, open observations for geoscience research and education, and lastly, but not leastly, is certainly we hope to improve the human condition. Just a couple of quick facts about UNAVCO. We have a 4-decade-long history of providing responsive and innovative facility support to the U.S. and global geodetic community. As you'll see a bit later, UNAVCO and the IGS kind of grew up separately, but in parallel over the same time period. We're a nonprofit university-governed consortium. We have about 120 academic members, primarily degree-granting institutions in the US, and we have about the same number of foreign associate members. And I suspect that many of you attending this workshop are from an institution that is either a member or an associate member. Our membership has increased 8% since 2016, which is impressive. Now on to the GAGE facility. The GAGE facility, as we'll discuss in some more detail later, is the current incarnation of the National Science Foundation's U.S. geodetic facility. I am in charge of the geodetic infrastructure program. It's a very broad program and has an annual budget of $10 million a year. We have 36 staff members, including engineering managers of various rank and engineers of various rank as well that support the activities that are part of the GAGE facility scope. We support principal investigators. We support community and continuously observing networks. We support NASA and the Global Geodetic Network, as well as, I didn't add it on to this slide, but we also now support Shake Alert, the US earthquake early warning system. And we also support the general geodetic community through what's called geodetic instrumentation testing and support. This used to be called development and testing, and Freddie is the head of that group. So section 2, a little bit about the relationship between UNAVCO and the community. We take essentially all of our direction from the community and governing documents, in particular a document like this. This was a National Research Council study that focused on precise geodetic infrastructure and what we needed. This was published in 2010, and it was updated with a new report in 2020. One of the important things in this report was an effort to move from GPS only to multi-constellation GNSS. And as part of that, to better integrate the 4 global geodetic observing system technologies to improve our ability to resolve the International Terrestrial Reference Frame, and as a result of that, also improve precise orbit determination for low Earth and mid-Earth orbiting satellites. This was the updated version of that. In that updated version, you can see that there's a pyramid of different aspects to geodetic infrastructure. At the base of it, of course, is the actual observing technologies that we have: SLR, VLBI, GNSS, DORIS, the archives, expert data analysts, and software that allows us to integrate and produce data products from these raw observations. This in turn feeds into the terrestrial reference frame, produces primary geodetic products, supports Earth orbiting missions, which can lead to direct geophysical observables that enable us to solve a wide range of science problems. Just a quick overview, a typical GNSS station has a monument, an antenna enclosed in some sort of array dome, some sort of enclosure that holds the telecommunications infrastructure as well as the receiver. Most of the stations that UNAVCO supports are remote, and therefore they are powered by solar energy, and then the data need to be telemetered back. And what's most important about this is while we started our adventure in GPS and GNSS as focused on positioning primarily and using that positioning information to understanding something about the dynamics of the solid Earth, we can also use this same technology for remote sensing through the direct GNSS signals as they travel through the ionosphere and the troposphere. And we can also get additional information from reflected GNSS signals. So there are many applications of these GNSS stations that are globally distributed. This just shows you UNAVCO's current holdings and support for projects around the globe. You can see that we've supported thousands of campaign observations, as well as thousands of continuous stations. This slide was just given to me by Dave Minson. It was made by Brooks Mershorn. It's a very interesting slide that shows the evolution of campaign GPS and GNSS data holdings in the UNAVCO archive. And as you can see, each one of these bubbles represents an individual station data holding, and the numbers, the size of the circle scale with the number of observations. And the peak of this occurred somewhere in the late 90s, early 2000. And as you can see, it's been declining ever since. And as this has been declining, the role of continuously observing GNSS observations has been increasing over this same time period. So now just to connect back to the IGS, the International GNSS Service, as you can see, its mission is quite similar to the mission of UNAVCO. It's to provide services on an openly available basis of the highest quality GNSS data, and to facilitate Earth observation and research in PNT and other applications. There's a couple of areas where we have very, very strong overlap, and I'm going to highlight those right here. First of all, I believe we have a very overlapping mission and vision, and I think that's a good thing, even though we probably shared the development of some of those ideas together, because we've had a lot of participation from UNAVCO staff over the years, which I'll discuss a bit later. UNAVCO and IGS have a commitment to fair data principles and growing global geodesy for a wide range of applications. We both grew independently, but in parallel, and UNAVCO staff have participated in various roles within IGS since the early 1990s. UNAVCO's primary contribution to the IGS is through our support provided by NASA. And that support provides ongoing operation and maintenance support for the global GNSS network, the Space Geodesy Project, and the IGS Central Bureau. And I'll talk in more detail about those things in a sec. GAGE Final Precise Daily GPS Processing used IGS data products in the past when there were two independent processing centers, one using GYPSY and JPL data products, and the other using MIT's Gamut, GlobK, and IGS data products. And notice RT-GNSS system is running several processing engines, including one from Wuhan, otherwise known as PRIDE, that is currently using MGEX products from IGS. So now a little bit of history and why the commitment to our joint mission and vision is important. This is a slide from a presentation showing the IGS experimental network in 1992. As you can see, there were only 20 stations distributed around the globe, and they were all GPS only. And essentially, most of those stations were turbo rogue receivers. This is what the IGS tracking network looks like now. There's 511 stations. 62 of them are provided through NASA and the global GGN. UNAVCO provides another 35 stations. So UNAVCO manages and contributes about 19% of the total stations in the IGS tracking network today. I just wanted to tell you a little bit about our staffing, because none of this work happens at UNAVCO or at the IGS without people. And one of our senior managers who works directly for me is Freddie Bloom. He's been with UNAVCO for more than 2 decades, I think closer to 3 decades at this point. And here's the rest of our team. We have Kimber de Grand Prix, who just started at UNAVCO. She's had some experience working with NASA in the past, and we're really looking forward to having her as part of the NASA team. Jacob Sklar, who spent 20 years at UNAVCO, most recently over the last decade or so, supporting the NASA GGN. Dave Maggard, who's been at UNAVCO for 23 years. He is primarily responsible for many aspects of the IGS Central Bureau since 2015. And I would be remiss to forget about Sarah Dolger, who used to work for the NASA GGN, has been at UNAVCO for 18 years, but recently moved over in 2021 with a promotion to running one of the NOTA regions. This is the global tracking network for NASA. We have 62 stations with 66 receivers. 60 of 62 stations have been upgraded to GNSS. The red dots are stations that are currently offline. The data return for this network is over 90%. And that's a tribute to the NASA team at JPL and the team at UNAVCO that does an awful lot of coordination with our local station hosts to make sure that these stations continue to deliver data to NASA and JPL, as well as the IGS. So just a quick update on what's going on. The NASA Space Geodesy project provided funding to UNAVCO to complete deep drill brace monuments and geodetic ties to the VLBR and SLR stations in Texas and Hawaii. There's some additional upcoming field work that's going to occur at the multi-technique facility at McDonald in Texas, including to enhance our ability to mitigate any lightning strikes going forward. The GGN is operating at about 95% uptime with 92% data return. We're going to be recommissioning the Easter Island station soon as the MOU is complete. We completed a field visit to the Harvest Oil platform to get that one back on track. The Space Geodesy project is one of NASA's initiatives to enhance what is called the Global Geodetic Observing System and drive our ability to improve a number of factors with great importance to precision geodesy. UNAVCO has done work at 3 different stations: the Greenbelt Station, the McDonald Station, and the stations in Hawaii. The goals are to eventually yield 1 millimeter reference frame accuracy with 0.1 millimeter year stability to the frame, and tight locations of various methods to improve precision orbit determination for various low Earth orbiting and mid Earth orbiting observing systems that NASA and in fact other nations are currently supporting. One of the keys to this is building good monumentation. And UNAVCO pioneered, along with the SIGN network, the broad use of what are called short drill braced and deep drill braced monuments. We also do driven monuments now that are also of a similar design, but are not drilled in, but are just driven to refusal. And these have proven to be the, let's call it the platinum standard for geodetic monumentation. Just some quick pictures showing you the UNAVCO team, Sarah Dolger there on the right, our drilling contractor doing a deep drill brace monument at McDonald Observatory. This is a beautiful green open field, as you can see, and that gets transformed into these now new VLBI dish and closely tied GNSS stations, both with regard to the SLR station here in one location and the VLBI station here down in the lower portion of the McDonald Observatory. And all of this is accomplished by putting very tight control using laser ranging between all of the GNSS monuments and the other geodetic techniques. So just a quick update on IGS participation by UNAVCO staff and the Central Bureau support. Dave Maggard has been serving as the IGS network coordinator since 2015. He spends a lot of time wrangling IGS station metadata and new IGS station applications. He coordinates with GNSS equipment manufacturers to get the appropriate info into the IGS system that benefits the global geodetic community. And he also serves on the ART real-time GNSS working group as the UNAVCO representative. Freddie Bloom serves on the IGS Antenna Working Group and also obviously on the Workshop Organizing Committee. And previously, Chuck Meertens, Fran Bowler, and Lou Esty served on various working groups in the Executive Committee. As I said previously, through UNAVCO efforts and support from NSF, NASA, and the USGS, and the National Geodetic Survey, we contribute about 19% of the IGS stations. We built and previously maintained the IGS Site Log Manager. We designed and built and maintained TEC, which supported RINEX 2.11. The development has halted and has now been Dockerized with the retirement of Lou Esty, but TEC's replacement is on the way. It's going to be called Granite, and it's to be released later this year. We built the IGS website and maintain IGS org domain. Future support for this is currently under discussion. And we've also provided support for various IGS meetings at AGU, for example. As I said, the GITS team at UNAVCO, headed by Freddie, also does a number of other things that support global geodesy. We do independent GNSS receiver evaluation and firmware validation. We do GNSS receiver performance and mitigation during RFI, antenna testing, GNSS and data communication integration, extreme temperature testing, and we publish all of our findings online through what is called the knowledge base, and give this information away to the entire community, and I hope with benefit to the entire community. Just a couple of quick pictures. Here's one of our facilities where we test various receivers. This is a snapshot showing you how we can use various technologies to evaluate RFI and use various filtering technologies on the receiver or external to the receiver to mitigate those effects. And here's just a snapshot from the web page showing where this information is published. The next section I'd like to address is the role of UNAVCO, its current status, the GAGE facility, and NOTA, which is our largest network. So many of you may know the EarthScope program was a major NSF initiative. It was funded and started in 2003. Excuse me, I advanced too fast. Oh. So we can get it back here. There were three components: a geodetic component, a seismic component, and a drilling component. The EarthScope program sunsetted in 2018, and after 2018, EarthScope's activities at UNAVCO were incorporated with what we would call the UNAVCO Legacy Facility and in the GAGE Facility 1 cooperative agreement. The total budget was $500 million over the lifetime of the project. The Plate Boundary Observatory, the geodetic component, was about $100 million in network installation cost and another $100 million for 10 years of operation and maintenance. So the total investment was $200 million. At the close of 2018, we proposed to federate a number of other networks and therefore provide a more efficient use of our resources across this hemispherical scale network that we call the Network of the Americas. And as you can see, the vast majority of the stations are in the Western US, but there are about 80 some stations in the Caribbean and about 120 stations in Alaska as well. Unfortunately, we did have to deal with one major hiccup, which was in 2019, NSF announced to the community that they intended to de-scope and decommission about 10% of the stations. And they commensurately cut our funding for operation and maintenance about 10% simultaneously. These stations are relatively uniform in their design and operation. As shown previously, this is a beautiful picture from a station in the Caribbean showing one of our drilled braced monuments the GNSS antenna, enclosure, solar panels, and in this case, all of the stations in the Caribbean also have meteorological instruments that give us relative humidity, temperature, pressure information. This is a look at the inside of a typical station. This one is in the Western US. As I said, most of these stations are autonomous. Some of them have been operational for over a decade without a single station visit, which is a testament to the engineering and ruggedized nature of their installation. We produce data products related to this, and as I'll discuss later, there's increasing pressure on near real-time and real-time data and data products. The GNSS data products are now Rhinex, and we've been supporting Rhinex 2. We currently support Rhinex 3, and we are moving to be able to support Rhinex 4 in the near future. We produce level 2 products, which are station positions, time series, and velocities in various reference frames and with various upgrades and reprocessing efforts, most recently completed a couple of years ago into what we call Repro 3 in ITRF 14. We're getting ready right now to be moving towards ITRF 2020 and another reprocessing effort. We also support community contributed products such as PBO, H2O, and other reflectometry products. These other products are also part of our data system, but don't have much relevance at this time to the IGS. This is just a quick example of two very long stations. One is a campaign station that's been in place since the early 90s. At the advent of UNAVCO as well as the IGS. And this is one of the NASA GGN stations that's been operational since 1995 in the Caribbean. At the close of the EarthScope project, the capstone was to produce a velocity field for Western North America and Alaska. And this velocity field was published in a paper, Herring et al. In Reviews of Geophysics. It was based on a combination of both JPL and IGS orbit and clock products. Lastly, we have moved into supporting what is called Shake Alert. And right now there's over 1,100 NOTA stations distributed throughout the Western North America, Mexico, and the Caribbean. And out of those stations, approximately 900 of them are real time. That is, they're delivering uninterrupted data flow at 1 hertz. This is part of the USGS earthquake early warning system and is currently operational in the Washington, Oregon, and California. And UNAVCO was responsible for upgrading approximately 180 NOTA stations to make them robust and multi-constellation GNSS to support Shake Alert. And now we're responsible for the entire data system and data architecture for Shake Alert and integrating GNSS into earthquake early warning in the United States. So just a quick few notes here. I thought a lot of you might be interested in the future of the GAGE facility, IRIS, and the IRIS and UNAVCO merger. There's been a number of updates that have occurred over the last several years. Some of you have followed this closely, others have probably not paid much attention. In the fall of 2019, NSF informed IRIS and UNAVCO boards that it intended to only support a single geophysical facility after the close of the IRIS SAGE seismic facility and the UNAVCO GAGE geodetic facility. They formally announced this in January 2010. Both facilities are funded through a 5-year cooperative agreement, and both expire in September of 2023. As a result of this information, IRIS and UNAVCO formed a joint merger negotiation committee established in fall of 19 to study a possible merger between these two university-governed consortia and to draft terms for the merger for board and membership consideration. Both boards voted separately to approve the terms of merger in summer of 2020, and then the member representatives from IRIS and UNAVCO voted overwhelmingly to approve a merger in fall of 2020. At that point, we moved from planning a merger to merger implementation and empowered what are called the programmatic planning teams, who've been working very, very hard since the fall of 2020 to actually make this happen. Based on an extensive review of the SAGE and GAGE facilities and an NSF AC geophysical instrumentation portfolio review, NSF announced in June 2021 its intention to extend the existing cooperative agreements for SAGE and GAGE through 2025, but no formal action yet has occurred. So the initial merger of IRIS and UNAVCO into what's going to be called the EarthScope Consortium will occur in December of 2022, so not very far away, with the goal of full operational integration by fall of 2023. So we also expect a new NSF solicitation for the Singles Future Geophysical Facility in early 2024, with a decision on the new operator by late 2024 or early 2025. So now I'd like to turn my attention to a few science snapshots from NOTA. I'll go through these quickly because I want to make sure we leave enough time for some Q&A at the end of this talk. So I've outlined 4 examples here that are primarily from our community principal investigators, with some help from UNAVCO staff in some cases. The first one's going to be the characterization of episodic tremor and slip from GNSS and BSM in the Cascadia. The second one is related to using GNSS for hydrogeodesy and studying crustal loading and how that is impacted by decadal scale of variations in precipitation. Last, I'd like to show some results from the magnitude 7.1 earthquake and applications of real-time GNSS for earthquake early warning and earthquake magnitude determination. And the last one is just how we can improve hurricane tracking using GNSS-derived troposphere estimation. So Cascadia ETS, as many of you know, subduction zones around the globe have now seen increasing characterization of a pattern of episodic tremor and slip. And this was first discovered using campaign measurements, but really characterized in great detail using continuous GNSS observations, as well as data from borehole, strain meter, and seismic observations. The seismic stations, the borehole strain meter stations are shown in red. The GNSS stations are the squares, and the locations of all the earthquakes are shown as the light circles. And you can see the evolution of the episodic tremor and slip in the right panel as it starts in this central region for this particular example and moves both to the north and south, but at differing rates. And constraining this can only be done when you have great continuous observations of high precision. This was also shown with the borehole strain meter data, again showing you the evolution of the earthquake swarm shown here, starting in the center and migrating to the north and to the south, and being very well characterized by our high precision Gladwin tensor strain meter observations. The next example is from crustal loading. Using the entire, at the time, what was the PBO network. And in the first frame up here, this work is from Borsa et al. It was published in Science in 2014. You see vertical displacement as a function of time. And in early 2011, the crust was being depressed relative to the average over the entire period. And as you move forward in time, the crust was rebounding and moving upward by about the same amount. And in the lower panel, we show rainfall from a variety of sources that have been put together by Borsa and his team. And you can see that there was very high rainfall in the period of time when the crust was being depressed. And that rainfall through this decadal scale, drying and drought decreased, and then the crust rebounded. And you can do this across the entire United States and use the same information and examine seasonal climatology using Geodesy to help provide additional constraints on large-scale climatology. My next example is just showing you how you can use a well-positioned GNSS network to help constrain observations that can lead to better magnitude constraints for large earthquakes. And these are just showing you some pictures from the area in the Mojave where the Plate Boundary Observatory had a relatively sparse network, but yet it still provided incredible information. So this animation from Kathleen Hodgkinson shows you how the earthquake initiated, the relative moment release in the upper right-hand corner, the GNSS horizontal displacement, and how the magnitude evolved with time. And the take-home message here is using a network that was not designed to be a part of an earthquake early warning system, we were able to accurately determine the earthquake magnitude within about 13 seconds after the initiation time of the rupture. So, and our last example here was provided by John Braun from UCAR and the COSMIC program. And this is showing you a near-infrared viz overlay from Hurricane Isaac in 2012. And the real-time, wasn't quite real-time, near real-time determination of the zenith wet delay during the evolution of this hurricane as it passed through the Eastern Caribbean and over the Greater Antilles. And if you examine on the right panel, what you can see is the red track was the conventional data assimilation methods that are used most widely today. The green track is when we take the coconut precipitable water vapor and add it to the assimilation, and the black track is the actual best estimate from the National Hurricane Center. And so you can see the addition of terrestrial-based GNSS observations, provided they can be made available in near real time, can also enhance our ability to do numerical weather simulation. Just a number of challenges going forward. And I see that I have a couple minutes left, so I can slow down a little bit and we'll still have time for questions. Freddie wasn't sure I could get through all of this in the allotted time, but I guess I was able to do it. So the first significant challenge that I'd like to present is that we now have increasing demand for real-time or near real-time GNSS streams, advanced and custom data products, and analysis, because everybody wants to do analysis, and it doesn't matter whether you're a scientist or you're Google. This presents some challenges related to open data access and the balance of basic versus applied science and commercial applications. And I'm not here to answer those questions, but it's for groups like the IGS and other community-based groups to evaluate the appropriate balance as we move forward. The next issue is we have an aging geodetic infrastructure, in particular with regard to NOTA. And there's been no real long-term commitment to continued technical enhancement and rejuvenation. And yet, as I showed in my science snapshots, this technology and network can provide powerful and leveraging observations to answer a number of Earth system and geophysical scientific problems. The other next issue is really a profound issue, and it's getting worse every day. And that is that we've had flat or nearly flat funding for a decade, despite real and now increasing inflation that impacts all aspects of UNAVCO and GAGE facility operations. And we've seen this this year, this summer, as we're coming out of COVID and trying to get back to work, and gasoline prices are double what they were over the historical period of a few years prior. And this is making a big impact in our ability to keep our network operational, because the funds were set and the budget was set some 5 years ago. Other issues that I consider to be very, very important are staff retention and continued personal growth. And both IRIS and UNAVCO have been operating in a remote to hybrid work model since March of 2020, when the COVID pandemic began. And this has had some really significant impacts on a number of issues, not the least of which are esprit de corps, onboarding of new talent into our organization, and ability to generate new ideas by less structured interactions. And the last two are the two big ones. One is the uncertainty and complexity associated with the IRIS-UNAVCO merger into the EarthScope consortium. While senior management and the boards and community members have been doing an excellent job trying to steer this, this is the first time that we've ever tried to merge the two largest facilities in the NSF Geo Directorate. And so this is a very large undertaking, and frankly, it's not our day job to do this. So this is taking an enormous amount of additional work on the part of a large number of staff and the joint boards of IRIS and UNAVCO. The last and most important issue is the uncertainty regarding the outcome of the recompetition for the future geophysical facility after the close of the current SAGE and GAGE facilities. So we have to get the merger done first to put us in the best position to recompete as the EarthScope consortium going forward. And hopefully we will be able to win the competition and continue to provide excellent support for the global geodetic community and the IGS going forward. And just an acknowledgement of our sponsors, the National Science Foundation, NASA, and the USGS. So that ends my formal presentation, and I'm happy to answer direct questions about the presentation and participate in any Q&A that Freddie is going to moderate.
Thanks, Glenn. Well done. So we have quite a bit of interest in the chat about the upcoming Granite software, and I'm not sure how much detail you'll be able to address these in, as you'll say this is being done in the other directorate of UNAVCO, the Data Services Directorate, but question specifically, will it do data translation? I imagine that the T in Granite stands for translation and editing. Yes.
So the main issue, I am certainly not that close to this, Freddie, as you know, but I do know some aspects of it, and maybe there may be some folks on the call that could chime in and give a little bit more information. But as we move towards more and more real-time operations, we developed our own translator to be able to produce whatever type of output we would like from our input Binex streams. We intend to also be able to support a limited number of receiver combinations to produce various types of Rhinex and other data formats as well. And the whole data architecture is, as we're moving out of our building and are removing our on-premises data systems and moving everything into the cloud, where the Geodetic Data Services team is working closely with the data services team at IRIS to create internal formats that can be tapped to produce data in any format that a user can request, basically on the fly. And so I saw Dave Maggard had some comment. I'm not reading the chat, Freddie. Yes, and I will clarify that the IGS network page is not the entire IGS website. So indeed, there's many other aspects to the IGS website.
Do you have a feel for whether Granite will handle Rhinex 3, Rhinex 4, Rhinex 2? I imagine that it will be,
yes,
compatible.
We will be producing Rhinex 3, and I brought up at our last analysis center meeting the issue of Rhinex 4, which was recently announced, and whether or not we had to deal with that. And it was my understanding that from a processing perspective, that Rhinex 4 is really only going to change the way metadata is handled in the Rhinex header. I'm not positive about that. I have not researched it in any detail, but I will make it clear and ask Dave Menson, who's the Geodetic Data Services Director, to produce a Q&A sheet related to the release of Granite. So I'll take that message back to the team.
Sounds good. So Myra has a question. Has the CocoNet data continued to be used recently to more recent events like Hurricane Maria in 2017 or more recent storms?
Yes, okay. Well, there's been some issues related to CocoNet and CocoNet's uptime and performance. I don't want to belabor it, but the CocoNet award expired in 2016, and it was unfunded from between 2016 and 2018. And because of those not earthquakes, but there were some earthquakes, but because of the hurricanes, many stations were impacted and needed to be renovated. Right now, the highest priority for NOTA is to get the CocoNet stations back up and running, and we've made great strides in that regard this summer, since many of these countries have opened up and we can start visiting them again and coordinating with our local partners. So as far as other folks using the data, I can't say. Maybe John, John Braun, who's on this call, I imagine, as a part of the organizing committee, he might be able to comment on whether other hurricanes have been studied, similar to that Isaac event of 2012.
There was a series of data assimilation experiments that did happen prior to 2016. But Myra, one person who has been interested in that is people who formerly were at the Naval Research Laboratory, and I don't think that that has had any movement forward recently.
Yeah, we can talk offline. This was really insightful and good. Hopefully the network gets going on.
Yeah, so I will go into a little bit of the data assimilation nomenclature. And so now that Ben Rustin is at the Joint Center for Satellite Data Assimilation, I think that it's an appropriate time to see the value of CocoNet within the JEDI system.
Really good. I'll keep in touch with you and Ben. I'm interested in some potential applications, but thank you.
Thanks, John.
Okay, in the chat, David Maggart did clarify that UNAVCO helped build the IGS network page, but not the entire IGS website, much of which was developed by IGS staff in Pasadena. And Tom Herring clarified that RINEX 4 observations are the same as RINEX 3. It's the broadcast ephemeris format that changes from version 3 to version 4. That's it for what's in the chat right now. If anyone else would like to raise their hand, jump in and ask any more questions. Otherwise, we will close this and transition to the next working groups. Jeffrey Crefton asked, does UNAVCO plan on making Granite closed source like Tech was, or does UNAVCO plan on making parts of the code available by end user license agreement or parts of the code open source?
I think the short answer to that is we're going to use end user license agreements, knowing who was in charge of the development of this tool, I believe that there's every intention to make it as open as possible. But of course, that is going to, we continue, as Freddie knows, we continue to try and work with some of the GNSS receiver manufacturers to get access to the proprietary information and formats in order to make the translation part of the code more readily available.
Okay, last call for Tom, you have your hand up?
Yes, I do. Yeah, I was just wondering if you wanted to comment more on the transition into cloud computing and what you see the impacts of that being on things like RINEX 4 formats and the way data is actually ultimately going to be stored.
Yeah, Tom, I don't have a lot of insight into all of the ins and outs in it, but I know that we're moving away from storing. So it's not just a lift and shift, but we're redesigning the entire architecture about how the data is going to be stored and how the metadata is going to be stored, and then building backsides that can produce the data in any format that the user would request. And so, the details of RINEX 3 versus RINEX 4, we'll have to address those and ask Dave Menson and his team to give a presentation going maybe soon or at the next meeting.
Any last questions? If not, well, thank you again, Glenn. Much appreciated, great talk, and great to inform everyone on what UNAVCO's doing now and in the future.
Thanks, Freddie. And thank you all for pointing out a few of my errors. They're all mine. I'm sorry for that, and I will correct them. I don't know if this, if the PDF is going to get posted, Freddie, but I'll fix those issues and I'll send you back a revised PDF.
Sounds good. The talk is recorded and will be posted. Errors and all.
Errors, warts and all. All right, there you go.
We will now end this session and transition to the working group sessions, which will start in about 5 minutes.